This video is video 0 in a series of bashing geometry with complex numbers. So this video is different from the others in that it actually covers 0 complex numbers, like actually bashing geometry with complex numbers material at all. Instead, this video reviews definitions and like basic constructions. So if you've already know what a complex number is and how to, for example, multiply them and work with conjugates, etc., then you can skip this video. And you should also know the key properties of circumcenter, orthocenter, incenter, and centroid. So let's get started. So mathematicians defined the number I to represent the square root of -1 because there's no quote-unquote real number that satisfies this. And so complex numbers are numbers in the form a plus bi, where a and b are real numbers. So here are some examples of complex numbers. Alright, so now let's try adding some. So if we have a complex number a plus bi, and we want to add a complex number c plus di, then it'll just be a plus c plus b plus di. In particular, if you add two complex numbers, you'll get another complex number. And what if you multiply them? Then you can just use the distributive property and expand. And you'll get this. So that's how you add and multiply complex numbers. And dividing isn't too important. Actually, multiplying and dividing aren't too important for bashing complex numbers in geometry. But search up like division, rationalizing the denominator if you're interested. Alright, so now how do we deal with conjugates? And what even is a conjugate? So let's just say we have a complex number z and we want to find its quote-unquote conjugate. So first, what is a conjugate? So let's just take any complex number a plus bi and define its conjugate to be a minus bi. So for example, the conjugate of 3 minus 4i is 3 plus 4i. So the conjugates have very nice properties. Let's just say we're trying to find the conjugate of, let's just say x, y, and z are all complex numbers. Suppose that we're trying to find the conjugate of this expression. Well, so the key property of conjugates is that we can break them up like this. And this is really good for simplifying things. And we'll discuss this in the first video, but a key property is that and also now we'll define magnitudes because they fit in well. So the distance let's just say we have like a complex number z, and its magnitude is defined to be its distance from the origin. From the origin meaning 0 in the complex plane. So for example, we'll define like the complex plane stuff in video 1, but let's just do like a simple a plus bi. So the magnitude of a complex number a plus bi is the square root of a squared plus b squared. So that's something nice to know. So if the magnitude of z is 1 and z is a plus bi, then a squared plus b squared equals 1. And so if the magnitude of z is 1, then the conjugate of z is equal to 1 over z if the magnitude of z is 1. And we'll see why in video 1. But it's not that hard to do, so try figuring out why. Alright, so that's enough with complex numbers. Now we'll move on to the definitions of triangle centers. So imagine that we have a triangle, and let's start with orthocenter. So we have any triangle ABC, and so let's just draw all its altitudes. It's a property that all the altitudes are concurrent, which we won't prove in this video, so just assume that they are for now. So concurrent means that they all meet at a point. And those three altitudes, and altitudes are the lines that go to the other side in a right angle. And those all meet at the orthocenter, H. All right, now let's do G. And the orthocenter is usually denoted H. So now let's do medians. So medians are defined as the line connecting a vertex to the midpoint of the opposite line. So here are 3 medians. And they all meet at one point, which means that they're concurrent. And this point is called the centroid and is normally denoted G. Okay, now the circumcenter. So notice that any triangle can be inscribed inside a circle, the circle passing through all 3 of its points. Just this, so, and first we'll find the center of that circle by looking at the perpendicular bisectors of each side. And the perpendicular bisectors are the lines that are perpendicular to the side, so they meet at a right angle, and they bisect the side, so this. And those perpendicular bisectors, those 3, they meet at a point, and that's called the circumcenter. And this is the center of the circle passing through all 3 of those points. And the distance from O to each of the vertices, all of those are the same distance because it's a circle, and that's called the circumradius. All right, so now finally the incenter, which doesn't play that big of a role in complex bashing, but we'll just mention it anyway. So now let's look at 3 tangents. No, not angle bisectors. So what are angle bisectors? Those are the lines that go through. So this picture isn't drawn well, but these angles are supposed to be the same. So this one and this one are the same. This one are the same. And this one are the same. And those 3 angle bisectors meet at a point I, which is the incenter. All right, so that's all that's most of the things you need to know before you can start watching the rest of the series. And so if there's anything that I mentioned in there that in the rest of the series that you don't know, that you're confused about, then just search it up. Or if it's like common, like I say like a definite, like the name of something, or if I say something confusing, just drop it in the comments. If you like this video, please like and subscribe. Thank you. Also, let me know if I've made any errors in the comments.